Hey everyone, welcome to day 16 of my not thousand days, it's my daily lead code science journey, and today I'll be attempting to solve this problem on binary search. Before I start solving it, let me check if I'm properly hearing or not. Yep, my audio is being transmitted properly and everything is fine. Alright, so let's start. So we're Suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the array nums 0, 1, 2, 3, 4, 5, 6, 7 might become 4, 5, 6, 7. Huh? Wait, what? 4, 5, 6, 7. Okay. So this array is split in between, split in half, and the portion on the right hand side goes to the left hand side, but the order does not change if it was rotated 4 times. Okay, so 0, 1, 2, okay, 1, 0, 1, 2, 3. Wait. Okay, so rotated 7 times means uh, four. Four of the numbers go to the front. So we've got 7. It goes. It comes before 0 and 6 and then 5 and then 4. Alright. And 0, 1, 2, 3, 4, 5, 6, 7. If it was rotated 7 times. So 1, 2, 3, 4, 5, 6, 7. Okay. So if it was rotated 1 time, then 7 would be before 0 and 6 and 5 and 4 and then 2 and then 1 and then 0. This would mean that we will get the original array. All right, and notice that rotating an array a0, a1, a2, dot dot dot, an minus 1 time results in array. Yeah, all right. Given the sorted rotated array nums of unique elements, return the minimum elements of this array. When the sorted array nums of unique elements, return the minimum element of this array. So I'll just have to find the minimum number and log n time. Okay. Uh, it's it's like really easy to find the minimum number in n O of n, not log n. I'll have to use some sort of binary search algorithm. Original array was 1, 2, 3, 4, 5, rotated 3 times. Okay, so we've got an array which is rotated. Uh, we can get one if we can just if I'm able to just unrotate it. So like rotate it back to its original state and just take out the first element. That will give me the output. We're not even given the rotation or something. But the original array was okay. Return nums 0. So nums is wait. Okay, and it works. So lowest equals can of -1. So n is then the number can be negative as well. Okay, so for nums if low equals -5, 1, 2, 3, 1, if num is less than so low is equals nums 0, nums 1 to n if num is I have to find the minimum. So if num is less than low, then low equals num until run n of n. Okay, so there's something wrong with my algorithm. I'm getting second lowest as well. Maybe that is not such a good idea. If num is less than low, for I in nums, so for each number in nums, you get if number is less than low, then low equals num. Oh, never mind. I'll return low. I was returning the wrong time. Now that should work. Yep. Uh, it will. The time limit will exceed, but it didn't exceed. But this is not how I'm supposed to do. Even though I bet like 4% of the other people. So how do I solve it using binary search? To get time of log n. So guys, to get the time of log n, I'll have to kind of divide the array into array by 2 and like the new array, and I'll get the new array which is like half the length of the uh, original array, and I'll have to like divide it by 2 again. Yeah, and when I do it like yeah again and again until the array is until I get the like only one element in the array. If I'm able to like reduce the array by dividing it by 2 each time to have only a single element remaining in it, then I will be able to uh, solve the problem in log n time. I've got input nums equals I've got input nums, output x1. So I should have started timer before, but yeah, that's fine. Hmm. Given the sorted array nums of unique elements, then the minimum element of this array. We're not even given on how it is. So what I could do in here is so from this array I have to get one, right? So what I'll do is divide this array, get the midpoint. So 5 is the midpoint. while left is less than or equals to right. Hmm. Wait, it is not in sorted orders. But I'll have to find out the point where the rotation happens. So let me take another example. So where I've got this, I'll divide this array into two. So 1, 2, 3, 1, 2, 3. So 7 is the middle part. Hmm. Wait, is the like rotation point or like the changing point always at the middle? Suppose an array, no, it's not always in the middle, but yeah. So let's look at another example. Given okay, this array is sorted, so I can't use this as well. What I preferably wanted was an array whose middle element would not be a element that would just switch the ascending and descending order. Okay, so I just have to find seven and zero. So like I have to find a point where right uh right like the right element is left than the like less than the left element. So R equals so R is left pointer len nums minus one L equals zero. So R and L are left and right pointer while left pointer is less than or equals to right pointer and the mid pointer equals L plus R by 2. Hmm. While left pointer is while left pointer is less than or equals to the right pointer, what can I do is mid pointer. So I've got the mid and I've got to check if uh, nums n is greater than okay, so nums is unique. It's nums. So if it's greater than nums nums n plus one, and then nums n plus one LF. So F it was something like this, where 6 and 7 are just the middle elements. So 6 the middle, and m plus 1 is this. And hmm, if middle element is greater than that element to the right, I'll just return nums m plus 1 and lf nums nums m is less than nums right pointer, then so if nums m f4 is greater than nums r. So let's say nums r is true if nums m f4 is greater than 2. So if 4 is greater than 2, then what will happen? Uh, 4 is greater than 4 is greater than 2, then L equals M. So left pointer is equals to right pointer minus plus 1 left else R equals pointer minus 1. Then 0. Okay. Wait, what? Nah, 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 nah. This should not work. Like, there's something wrong with it. Yeah, alright, now. That's more like it. Uh, wait. Did it really just only pass these 3 test cases and nothing else? Well, that's a first. Let's index out of range. Oh, so LF F len nums is not equals to 1 and will this work? Probably not. Yeah, it kind of worked. Okay, well, that's some progress. So all these do not quite catch one. Why? Because okay, what's gonna happen is a left pointer is less than right pointer. This will be true. And we get mid pointer is L plus R, 0 plus R is R, 0 plus R is 0, 1, 2. So 2 into 6 and 2 is 1. So we get 1. F numbers M. So what's M? M is the middle point, which is 1 right here. If 1 is greater than M plus 1, then return. So 3 to 1 is a bit different in this case where it worked. It works here because okay. So this is the M, then M plus 1. So if nums M is greater than nums R, which is not true, as our right pointer equals M minus 1. So what's M? M is middle, so 1 minus 1 is 0, isn't it? R equals, okay, so right pointer is M minus 1 is 3. So 3, while L is less than or equals to 3. This is 3, and mid is 0. Okay, 0. The same thing is 0. So wait, f nums m equals 3, then Let me just run it to check something. There's no std output, so one. If I get std out one, this will break the entire algorithm. Uh, yeah, it didn't. For some reason, everything's fine. Why is everything fine? Huh? What if so? This does not really matter, does it? Uh, let's see. If nums m greater than 3, will it become 3? No. So will it become 1? Uh, yes, it becomes 1, but nums m is never 3. Well, so this will just divide it into 2, and if no, then as f numbers m, 1 is greater than plus 1. Okay, as num m is greater than, which is, so this is false. So the right pointer is over here, will be reduced from right pointer will be reduced from 1 to over here. Okay, let's check if no, the 3 is not 1 over here. Hmm. Okay, if I remove this, it still works, but it still pass 45 of the test cases, as it still does pass 45 of the test cases. Hmm. Okay. left len numbers as numbers. If numbers is not equals to 1 and I need a better test cases. Test case. Oh wait, 3, 2. Okay, what about this? Why? Oh, that's why I had an extra comma over there. Alright, so I've got a better test piece here. I got 3 as an output. Uh, the expected was 1. So what happens over here is minus 1. So that's test piece number 3. Hmm. So I've got nums equals this, and that's and I got output as 3, where I was expecting 1. Okay. Hmm. Output 3 expected is output is 1. And number is, why am I getting 3? I'm getting 3 because of this thing pass. Okay, elif number and mid is if this is greater than nums in R, which is if this is greater than this, which is true, then left is n plus 1. So over here, 2 over here. Alright, uh, so this is fine. This is good. And as right is mid minus 1 mid. Mid okay, okay, okay. Right. So I've got 6 and then 7 is the starting point, right? So I'll go 7, 7, 1, 2. And this array where elements that I've got 3 elements. If len numbers is not okay, is no std output. Print nums m. So after running this, I can see what I get. So now I see the problem. Okay, so never mind. It's like it ran for 2 times over here. What? How did it? Okay, okay, okay. All right. So it was 3. So my loop only runs once. In this case, I'm just getting stuff right there. Over here, at least 5, 1. Is there something wrong with my while loop? While left is less than or equals to right, right is obviously 2, left is 0, which is true. Print L, print R. Okay, so I've got 1, 0, 2, 6, 0, 1, 2, 3, 4, 5, 6, 7. Okay, all right. Yeah, everything's checks out. Mm, so let's look at the left and right. This is after this. What? So left and yeah, so 4, 6. While left is less than or equals to I, so 4 is less than or equals to 6, which is true. Print element. Okay, here's problem. So 4 is less than or equals to. Left is less than or equals to. So 6 and 6. Left is clearly less than 6. I don't really get what's happening over here. So let me just ask ChatGPT what it thinks. So कोई files management, include parameter. Oh wait, what? Oh, that's why. Wait, so it should be over here. Like what? This is clearly written an error because written is outside the function. What the hell is happening with my indentation? Alright, now that's fine. Yeah, unexpected indentation. Alright, now this should fix everything. Yep, everything was wrong because of the indentation error. Now this is fine. Let's check for D7. That is 4 where it should have been 1. So why am I getting the error? Let's check. Left pointer is at 4, R is at 3, and then I've got mid equals 1 if len and m is greater than or equals to m plus 1. Eh, like this might work. And I might exceeded the time time limit. Okay, this 4, 5, 1, 2, 3. If left is m, if m is greater than f nums m equals 5, then so num is not equals to 5. Then m. Let's see what are the middle values I get. I get 2 and 0. It should be 2 and 1, not 2 and 0. There's definitely something wrong. Oh, okay. So it's 2 and 0 because right pointer decreases by 1. So right pointer is 1 and 1 integer division 2 is 0. Yeah. How can I fix it? Hmm. So the index is 2. Zero, 1, 2. Uh, F and 5 and equals. Let's see if this works. No, it didn't work. M equals 0, then M equals out of range. Hmm. It's valid. L plus R 0.5 and it's 1. Yeah, no. Print L plus R into 2. Okay. Uh, yeah, no. It does not really work. To get something else. The outputs for step 1. Uh, let's check with ChatGPT. Incorrect placement. Try handling single random. It's not correctly handled. Correct. And M is M is less than R. Wait, what does this do? It does not really fix the problem. So it's just another validation. And check if the middle element is smaller than the previous. If M is so, this might work. Yep, it does work. Let's see if it works for the entire solution set. Yep, it does. Battery's running low. Let's plug it in. All right, it's log n. That's great. Um, by log and solution was kind of 3 milliseconds faster than this. Uh, Maybe it's because I'm not doing it at the proper way. Uh, so I had not accounted for this. So what does this do? Nums m. So if the middle element is, oh, if the middle element is less than that element, it's, oh, okay. So I could do something like this as well. Or wait, no man, it does not work like that. Hmm. If length equals n equals length n equals 1, return nums 0. Okay, yeah, this works. Maybe I'll get a store time. Yeah, it's kind of the same as the one where I just manually did the stuff. Uh, Let me look at the solutions. Python solution. So, uh, left equals, all right, while left is less than right. Mid is mid equals left plus, all right. If, oh, that's fine, dude. If nums mid is less than nums right, what? If nums mid is less than nums right, then right equals mid and left else left equals mid plus 1. Yeah, makes sense. What? Mm, Start with two markers, one at the beginning of the path. Let's call it left. Markers help you track where you are. Answers like cutting through the maze, calculating the point, reading the signs. Now here's the trick. When you reach an intersection, you check the signs. If the sign at the midpoint is smaller, midpoint to a smaller number than the one at the end of the path, you know that tracer F's to the left. So move left. Okay, but as the solution faster than mine. Uh, yeah, no, mine is way. It's not way faster, but it is like twice as fast. But what? No, it is not that fast. Just trying to. Okay, I don't know what's wrong with this. Oh, so you can only use the analyze complexity thing once per day. Oh, I thought that it was once per account or something. That's way better than what I previously thought. Uh, yeah, I just solved it using binary search. Uh, I just took a little bit of help from ChatGPT to because I was kind of missing this concept. Yeah, I feel like looking at ChatGPT is better than looking at YouTube code because they'll just tell you all of the things that you like might not have figured out yet. So they'll just give you everything that you need to know to like kind of solve it. But ChatGPT will just fill out, will just point out a mistake in my code, which is like better than uh, like watching YouTube vid. Yeah. So it took me about 45 minutes to solve this. That's the code. So where's it? It was 1:53 a minute ago. Yeah. Let's see. Yeah, I've contributed 13. Yeah, all right. Uh, everything's fine, great. All right. Yeah. So guys, that was it for today, and I'll see you guys